Hello, and welcome to our poster where we are going to be discussing whether small modular reactors can keep up with wind power. I'm Joseph Rowland, and I'm joined by CJ Robinson and Elijah Bloom for this recording. And I will kick it off with CJ.
So just as a general overview of our research, the goal of our research is to determine whether or not SMRs can change their power output quick enough to load follow in different wind conditions. And the standards for how fast an SMR needs to change power output is given by the Electric Power Research Institute Utility Requirements document. And we're looking at the 13th revision of that. And so for our research, we mainly focused on the hourly requirement and the 10-minute requirement. These correspond to a 40% ramp rate in power output within 1 hour and a 20% step change in power output within 10 minutes. The data we gathered consists of 28 different case studies. The case studies are the result of crossing 4 different load data sets from January, March, August, and November with 7 different wind speeds data sets from days with sufficiently different wind speeds to better simulate a variety of wind conditions. And these case studies were taken both on IG and DFIG simulations, and Elijah will cover the differences of those later. For each different case study, we adjusted the total number of SMRs used so that the nuclear power output capacity is larger than the maximum load on any given day. So for example, if the maximum load in March is 37 megawatts, only one SMR would be used, and that's to account for the case where the wind power would contribute nothing.
We use 2 common generation systems, the induction generating system and the doubly fed induction generator system. And the DFIG has a larger range of power production that covers a lower and higher range of wind speeds as compared to the induction generator. Using rapidly changing wind data, we simulated the electrical power output from the 2 generator systems previously mentioned. Using the equation below, the nuclear equals load minus wind, we can then see what the nuclear power is going to be in order to match the load. Failures will occur in various types of the ramp rates when the SMRs can't keep up with the various ramp rates given. And you can see as such happens about 2/3 of the way through, where you see these drastic changes. And within that, this is the first of specific case that you will see that failure. This slide indicates the exact same thing within the DFIG system. A little bit before halfway through, you can see drastic changes that will occur and cause a failure in the system.
So once we know what our nuclear output needs to be over the course of the day for each case, we took the wind farm size and scaled it up in 1.5 megawatt intervals until one of our requirements was unmet. So here these figures show each of the 28 cases where the wind farm size got too big to be able to, for the SMRs to be able to keep up with, and thus failed our tests. Something notable here is that both in March and November loads, the failures tended to happen on the same point. So a lot of those November points are covering up the March ones. Also notable is that day 4 was a particularly calm day. So the SMRs were able to keep up with the wind farms for a long time before reaching a failure point. So the maximums and the minima of each of our 2 simulations are documented here. The largest IG wind farm that the SMRs were able to keep up with was 55.5 megawatts. The smallest IG wind farm that failed our SMRs was 9 megawatts. And then likewise, the maximum for DFIG was 189 megawatts, and the minimum, which failed our simulation, was 10.5 megawatts. We also have noted the average failure levels for each month. And as you can see from this slide, IG typically did not perform as well, and the SMRs failed to keep up with them at lower levels than the DFIG farms. Another notable result of our research was that 100% of our 28 case studies failed our test due to the 10-minute URD requirement. So thank you for visiting our poster. If you have any questions that you'd like to ask, please come visit our Q&A session on April 13th from 2 to 3 p.m. Thank you.